okay, we try to answer the question, okay, is the coin fair or not? Or more generally, how biased is the coin? So this how biased is a coin, this bias, okay, biased has three meanings. Okay, depending on the context, the meaning of the bias may be different. Okay, for example, okay, the first meaning is like what we use, like sometimes like I say, okay, you are biased. I say you are biased. I mean, because you may treat somebody better and treat somebody bad, right? So not fair. It's biased. Okay, so this is one first meaning. The second meaning is like okay, for example, how biased the coin. Okay, it actually refers to the probability of the coin flipped head. Okay, or more generally, okay, bias can be used as to refer to probability, a certain probability. Okay, so in this case, okay, it's like the probability that a coin is, I mean, coin flip. I mean, the probability the coin flipped is head. Okay, the third one, I forgot the third one. Anyway, just want you to be aware. Okay, when we say how biased is the coin, I'm not saying the coin is unfair. Okay, because coin doesn't treat somebody unfair anyway, right? It's not a person. I mean, just want you guys to be aware. Okay, so note about the terminology. When we refer to a bias, oh yeah, we will be referring to its underlying probability of coming up head. Yeah, I already. So when the coin is fair, it has a bias of 0.5. So other times, the term bias may be in curricular sense of departure from fairness, okay, as in head biased or tail biased. So this is more like unfair treatment, something like that. Okay, just want you to be aware. So you may ask, so why do we need to consider coin flipping? I mean, coin flipping doesn't, we don't do coin flipping experiment anyway, right? So why do we consider that? Okay, because coin flips are a surrogate for myriad of other real life examples that we do care about. Okay, do you guys know surrogate? The term surrogate. You can say it's a 替代品. Okay. Something similar. Okay. For a given type of heart surgery, we may want to know what is the probability that patients survive more than 1 year. Okay. If you define, okay, after a surgery, okay, the patient survive more than a year, okay, means successful. Okay, if after surgery the patient does not survive, okay, more than a year, as failure, then you can link the successful kind of like the coin flip, the head, and failure kind of like the tail, and this obviously like the surgery can be treated as a coin flip, right? Okay, so other cases like for survey question, we may want to know the probability of agree or disagree, right? So a question can be, if somebody answered a survey, for a particular question, the answer could be agree or disagree. Again, as long as the result is like a two-sided. Okay, you have two like results that cannot coexist. Then you can sort of link that event to coin flip. Okay, or in a two-candidate election. Okay, such as Donald Trump and Joe Biden. Okay, before the election itself, we want to estimate from a pool. We may want to estimate the probability that candidate, well, maybe Trump, will win. Okay, again, this event is, has two possible outcomes. Okay, so you can treat each pool estimate as one trial, like a coin flip. Okay, or starting arithmetic ability by measuring accuracy on a multi-item exam. Okay, for which the item outcome are correct or wrong. Oh, by the way, okay, in English, okay, if you see multi-item exam or multi-choice exam, okay, then okay, the answer is either correct or wrong. Okay, there's no like partially correct case. Okay, because if you direct translate multiple choice exam, I mean, if you direct translate that into Chinese, it becomes 复选题, right? But if you are in high school, the 复选题 means like you can choose like multiple answers for one question, so you can get partial credit, right? Okay. But unfortunately, Americans are dumb. Okay, they are stupid. They never have that type of exam. Okay, their exam, if it's choice type of exam, okay, the multiple choice just refer to 单选题, single choice. Okay, it's just you have multiple options, but from those options you choose one answer. Okay, in U.S. that type of exam is referred to as multiple choice exam. Okay, there's 我们的复选题没有在美国没有在做这个的。There's no our multiple choice exam. It doesn't exist. Okay, in U.S. Okay, so that's why. Okay, when we say multi-item exam or multiple choice exam, the result can only be correct or wrong. Okay, because there's no partially correct. Okay, so obviously, okay, for the first example, the heart surgery, obviously this type of question is important in medical field, right? Okay, for the second question, okay, this type of thing is important to social scientists, right? Because social science, do survey all the time. Okay, for the third question, okay, for political science, they care about this type of question. For the last question, okay, if you are into education field, or if you come from the fourth floor, okay, 那个就是那个网学所 okay, then this one is important to you guys. So you can see that for different areas, you can easily find like questions that are somewhat like similar to coin flips. So that's why the coin flips is a good example to start with. Okay. So the first thing we will do is generalize the concept of bias. So we will say that a coin with a bias of 1 always land heads, okay? And the bias of 0, okay, will always land tails, okay? And the one with the bias of 0.5 will land half of the time heads and half of the time tails. Okay, this is very easy, right? Represent the bias. Okay, to represent the bias, we'll use theta parameter. And to represent the total number of heads for n number of tosses, we'll use the y variable. So y represents number of heads in n trials. Okay? So according to Bayes' theorem, we have to specify the prior p of theta and likelihood p of y on condition of theta. Okay? So for p of theta, well, we don't know. Okay? It depends on, where we get the coin from, right? But when you are given theta, if you are given the probability that the coin flip is head, okay, then we can compute the probability of y, okay, given theta and the number of trial n. That one we know, right? So let's assume only 2 outcomes are possible. I mean, of course, as remember I told you, the coin flip can only be head and tail. I mean, a certain case, the coin can stand up, okay, meaning no head, no tail. But that's the rare case we can ignore. Okay, let's assume that never happens. Okay, so let's also assume coin toss does not affect other tosses. Okay, so when you toss a coin, it doesn't change the nature of the coin. If the coin toss change the nature of, for example, if you toss this coin once and the coin somehow when it hit the ground, it's somewhat like a bend, then obviously the next time you toss a coin, the probability changed, right? So it's just like the cube dissolve example. Okay, the first time you do this experiment it's not going to be the same as the second time you do this experiment. I mean, for these 2 samples, some part has changed. So we assume that's not the case, okay? Because we assume coin is much sturdier, much stronger, okay? So we'll further assume all coins tosses come from the same distribution. Okay, so based on this, assumptions. Okay, there's a random variable coin toss is an example of IID variable. Okay, these assumptions are important. Without those assumptions, we don't have IID variable. Okay, and it will become much more difficult. So this assumption should be reasonable. Okay, if you don't agree, then it's going to be much more complicated, as I said. So given those assumptions, okay, and the likelihood is the binomial distribution. So you have n number of tosses. If the chance to get ahead, okay, for a coin flip is theta, okay, the probability of getting y heads out of these n tosses is this one, right? I hope you still remember this, from your high school math. This is high school math, right? High school math, okay? So, let's still do it, okay, even though it's high school. Okay, so you have n coin flips. Okay, so you have y, okay, head, and you have n minus n minus y tail, right? So the chance to get the y head is theta to the power of y. The chance to get this many tail is y minus theta. Okay, n minus y. Okay, so you get this one. But how many possible, for example, like if you have three trial, and to get like if n is 3, y is 1, then you can be h, t, 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 h, t, t, sorry. Yeah, TTH. So basically, it's like 3 divided by 1, 2, right? It's like 这叫什么？组合数，是不是？ Yeah. So basically, you have like n divided by y and n minus y, okay, factorial. So this is that one. So this probability is called a binomial distribution, actually. Okay. So binomial distribution is discrete distribution. Okay. Depending on the value of y, depending on